This vintage map shows the standard model of the solar system we learn in school. It presents rigid, concentric circles, with planets running on separate tracks at different speeds. But that model only looks at planets in isolation. If we strip away everything else and look only at the positions of Earth and Venus, we can see how they physically relate to each other over time. This diagram tracks their relative movement. By drawing a straight line between Earth and Venus at regular intervals as they orbit the Sun, an intricate pattern emerges. It forms a geometric, five-petaled shape known as the Rose of Venus. That geometry is the result of a precise mathematical ratio. For every 8 years Earth takes to complete an orbit, Venus finishes roughly 13. The difference between those two cycles, 13 minus 8, produces exactly 5 petals. If the empty space between two neighboring planets yields perfect geometry, we have to ask what patterns emerge when we map the orbits of every celestial body out to Pluto. This animation applies that same tracking method to Mercury and Earth. Mercury travels much faster, completing roughly 25 orbits in the time it takes Earth to complete 6. Subtract 6 from 25, and their resulting pattern is a dense 19-pointed geometric star. If we trace the boundaries of these inner orbits, standard geometric shapes fit neatly inside them. A perfect pentagram plotted inside Earth's orbit rests its points exactly on Mercury's path, while a square framing Earth's orbit perfectly boxes in Venus. Moving out to Mars, the ratio with Earth is 15:8. This generates a 7-petaled shape. Because the mathematics here are slightly less exact than the Earth-Venus pairing, the resulting flower is slightly asymmetrical. This next tracking model shows Earth and Jupiter. Jupiter sits much further out and moves slower. As Earth laps it year after year, the lines connecting them weave a sprawling 11-pointed star over the course of decades. From Mercury to Jupiter, these planets operate within strict mathematical proportions. To understand how they maintain this alignment, we have to look at the physics keeping them on track. How do these exact ratios survive over millions of years without the planets drifting out of sync? They are maintained by a physical process called orbital resonance. It acts as a gravitational tether. When celestial bodies share mathematical ratios, their gravities regularly push and pull each other to lock them into stable paths. This diagram shows two bodies in elliptical orbits. Because the orbits are elliptical, speeds fluctuate. When the inner body passes the outer one, it exerts a gravitational tug that transfers angular momentum, a rotational force. That force slightly speeds up or slows down the outer body, self-correcting any drift and keeping their meeting points perfectly symmetrical. That same gravitational synchronization can act like a broom. If a stray piece of rock enters an orbit that hits one of these resonance points with a nearby moon, it receives a repetitive gravitational kick until it is thrown completely out of that space. We can see the physical proof of this in Saturn's rings. The distinct black gaps dividing the dense layers of ice exist precisely because orbital resonance violently clears out any material that tries to settle there. The intricate geometric stars and flowers we mapped earlier are simply the visual fingerprints of this exact same gravitational survival mechanism, now operating on a massive planetary scale. Further out in the solar system, orbits stretch into decades and centuries. The geometric interactions between the gas giants become incredibly dense and complex. This leads us to the final planetary pairing of Neptune and Pluto. Pluto has a highly elliptical orbit that physically crosses Neptune's path. Logically, these two bodies should eventually collide. This simulation shows why they don't. They are locked in a precise 3:2 orbital resonance, performing a synchronized dance that keeps them physically separated even at their closest approach. Because of that ratio, for every 3 times Neptune circles the Sun, Pluto completes exactly 2 orbits. That synchronization ensures they will always safely pass each other. With the mechanics of these individual layers mapped, we can finally look at the solar system operating as a unified whole. Instead of isolating pairs of planets, we need to observe the entire machine simultaneously, from the Sun out to Pluto. If we run the clock forward and track every planetary orbit at once, these mathematical relationships layer together, drawing a massive, glowing geometric mandala. Over 2,000 years ago, the Greek philosopher Pythagoras proposed a concept called the music of the spheres. He argued that the cosmos was an enormous instrument, regulated by the exact same strict, harmonious mathematical proportions that structure musical notes. Mapping the geometry of these orbits proves his ancient intuition. The solar system operates as a self-balancing mathematical masterpiece hiding in plain sight.